Hey everybody, this is Larry. This is me going with Q4 of the weekly contest for 55 minimum time to transport all individuals. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. Actually, I wonder, I think the first thing about this one is noting that all the numbers are small, right? K is small, N is small, basically M is small, though I don't think M matters that much. Okay, maybe a little bit, but yeah, they're all small, right? So immediately, honestly, I thought bitmask dynamic programming, right? Because you have 12 things. So the idea is that with bitmask DP is that, bitmask in general is that it's a power set. It allows you to measure every possibility of every person, 12 of them, because for every person you could either set them as being on I don't think they have a name for it, but let's just say left side or the right side, right? So each person, 12 people, can be on the left side or the right side, so each person can have two places it could be, and therefore it's 2 to the 12, which is small enough for us to kind of play around with. So that's basically the general idea. Bitmask sounds funky, looks funky, but that's all it means for me in terms of possibility. And I did submit a wrong answer that way, so spoiler alert, it is not the right answer. And if I could click it and it shows up, then I can show you. But for some reason, Leetcode is not oh, there it is. But yeah, Leetcode is pretty silly. I don't know how to. Okay, but yeah, but even though the dynamic programming solution is wrong, I want to go over it first, and then we'll go over why it's wrong, right? So okay, so what are the assumptions that I had when I was building out the dynamic programming, right? I was like, okay, well, I mean, it is almost certainly bitmask dynamic programming. That's what I thought at the time. Like I said, it's wrong, but that's what I thought at the time. And I go, okay, well, first of all, if k is equal to 1, then it's not possible unless n is also equal to 1, because then you just go back and forth and you just, I don't know, have too much fun. But I think now that in my correct solution, I did not need it. But I at the time, I thought I needed it. At least for DP, you do need it. But turns out you also need other stuff, which I didn't have. But yeah, so, yeah. And here I did pre-process the work. I don't know if it's necessary, but I try to pre-process the thing so that I don't have to do additional things in the loop later on. But okay, but so there are two states, right? I wish I could write on top of this. Right? How do I? This new UI is crap. Is there just like I mean, you see my submission? Why don't you let me just like edit them? Let me go to a place where I can edit them. Isn't like an edit button copy to whatever button? All right, Leetcode, you're being silly. Fine, okay. Sorry. Okay, fine. But in any case, I have two functions just to kind of keep it a little bit easier for me. One is cross 1, the other is cross 2. Cross 1 is going, and if I could write it out, I would have written it out. But it just goes from the left side to the right side, meaning crossing the island, right? And here, we just have to make sure that we have fewer than k people. And we did pre-process this, but so for every bitmask, we count how many people are crossing. If it's less than or equal to k, then now we pre-process the time it takes, which is the max of the people that took. I'm not going into this in that much detail because I'm not going into bitmask in that much detail for this problem. At this point, I feel like there's so many bitmask problems. I have a lot of explanations about it. Maybe I should do a general video about it. But in any case, the way to think about bitmask is just that for each bit, you have either a 0 and a 1, and you can use it to represent whichever you like. For me, in this particular problem, a 0 means that they're on the left side waiting to go to the right side, and a 1 means that they're already arrived at the right side. Of course, it's a little bit, you could go back and forth because you have to bring the boat back, but that's the general idea. And so that means that the number of bit count is equal to the number of people that are crossing at one time, and that has to be less than or equal to k. And now, if that is less than or equal to k, then we just do a loop to see who is crossing and then get the maximum time from that, and then we pre-process it in a p in 3 different things. 1 is the bit mask, which represents the people that are crossing, the time, which is just the time, and then C is the number of people crossing. I think, well, this is not necessary in the correct solution, but we'll go over why I thought I needed it in a second. But okay, so you have two functions. You have cross 1 and cross 2. Cross 1 goes from left to right. So then now we don't have base case. We have best is equal to infinity. And here we go for every loop. We go with mask and C. And this is just a very easy way to doing a bit mask n. And why do we need a bit mask n? Well, the way to look at this is just look at it one bit at a time, right? So if mask is 0, that means that they're on the left side. If C is 0, that means that they're also on the left side, or they're not crossing. So C is actually a bit mask representing the people that are crossing. So if C is 0, then it doesn't matter what mask is, right? Because we don't use this person. If C is 1, then it matters what mask is. If C is 1, mask is 0, then that means that that person is on the left side and has to go to the right side. So that's basic, and that means that this is equal to 0 and this is true. If C is 1 and mask is 1, that means that, well, the person is already on the right side, so it cannot cross. So then now it would just skip everything inside, which, you know, means that this is not a possible set of transition or crossing that we might consider. Otherwise, if we are considering, and this is the case that I was a little bit wonky about. So there's this case of infinite looping, right? Because if we only move one person, we can move one person back and forth and then go in an infinite loop, right? So the way that I thought I could handle it is by setting, okay, if B, which is confusing because I use C here, so my fault, but B, which is the number of people on the boat, if the number of people on the run, we only want to do this if this is the end. That's what I thought. This is not true, by the way. This is the wrong answer, because it turns out there is a case in which you want to go back, and we'll go over that in a second. But yeah, but assume that this is wrong. Just kind of look at it, and then otherwise, then now D is equal to the current. Now T is equal to the time it takes times the multiplicative factor on the stage, and this formula is given to you here somewhere. I don't know where it is. I think it's just here, right? Yeah. So this formula is given to you. That's the D, and then now we just update best is equal to this recursive formula of the previous best, and that means that cross 2 is going from right to left, which means that the boat is on the right side. Say we update the bit mask to contain C. And then we update the stage, and then we also want to add D because the time changed, right? So that part is dynamic programming, and I don't know why they don't have a horizontal scroll bar for me. So I had to do like some funky, like selection left right thing. Leetcode is silly, but in any case, so that is going from left to right, and so far this is just enumerating every possibility. We haven't talked about complexity yet, but you know we'll talk about. It's not even right, but we'll go over complexity in a second. And cross 2 is the opposite. It's going from right to left. And here, I actually wasn't sure about this in that only one person to come back. I don't know if there is a case in which you may want 2 people to come back, maybe. But I don't know. I mean, this works, so I guess not. But I didn't think about proving it. So this part was a little bit of YOLO. But otherwise, then now you have cross 2. If everyone's already on the right side, that's your base case, and you have 0.0. Otherwise, one person has to come back. And this is just the same idea as what we already went through, except for we only pick one person for every number. Yeah. And this is just updates. And I'm not going to go in detail because, yeah, this is the same as before. And also, it's just implementation of these rules. And that's it. Right, so we start off with everyone on the left side, and stage 0, we update stage 0 and all these things. And the reason why this is wrong is, well, you have this wrong answer. The reason why this is wrong is that apparently my assumption of we only want to send one person over if it gets us to the end, meaning it's the last person, is wrong. Because we have this input, you have 40 and 1, so you have a really slow person and a really fast person. Then what do? Well, if you only do this on the first turn, then it's going to be 40 times 1.82, which is apparently this number, I think. And you'll be wrong because the answer is 47. Why? Well, you take the 1, you go back and forth. Now the stage is in 1.11, even though it costs this times 2, so like 3.6 or whatever, right? Plus now you have 1.11, but then now 40 times 1.11 is just much smaller. It's like 44 plus 3.6 or whatever, and this is what you get, right? I mean, you could do the math, it's fine, right? And that's basically it. And I was like, okay, so I do have, because the reason why I had this was to remove cycles, because if I didn't have this, like I said, you'll go back and forth, you'll never solve it. You'll be really sad, right? But yeah, but this now shows that we need to kind of have this idea of going to a different stage. But if you go to a different stage, there may be like, for example, if you kind of keep on going back and forth, it goes from 1.82 to 1.1, but then next again, it'll go 1.82 again. So then now you're back at where you are. And from that insight, I was like, oh wait, then, well, first I was like, can I do it bottoms up, figure out to get it from the end states and kind of going back up. And I was like, oh wait, no, this is just like a shortest path farm. And then that's basically, I was like, oh, it is just like a shortest path farm. And then we have this code. And honestly, this code is very similar to the dynamic programming code, so I'm not going to go over in detail, but the idea is very similar. Here, we don't need anymore. But again, we're pre-processing all the possibilities, and that's what this code is for. But instead, we use a heap instead, and the heap will contain four things. 3 of these are states, which is similar to the dynamic programming, but one is the cost. This is just Dijkstra's algorithm, by the way. I don't know if I said that directly, but this is Dijkstra's shortest path algorithm. You have the cost, you have the bit mask, you have the stage, which is the stage of the multiple factor, and the boat, which is, the way I think about it, is you have the boat either on the left side or the right side. So that's basically where is the boat, and that's basically it. And here we have, and this is just regular Dijkstra setup, and everything is just the same. If you look at the transitions, it is exactly the same, roughly speaking, except for that we kind of converted to a Dijkstra, right? Including this thing to make sure that we don't process the same node more than once. But the states, as you can see, is the mask, stage, and the boat. And then, yeah, if the boat is on the left side, we're just trying to get on the right side. And this code is more or less exactly the same as before. This code is mostly the same. I mean, I wrote out the new states, but it's mostly the same. And then we just kind of keep track of, and this is just Dijkstra specific things, but keeping the same state, right? Meaning, can we get to this state in a lower cost? Yeah. And honestly, if you're not following me at this point, definitely work on Dijkstra's algorithm problems. There are a lot of them that are easier than this one, and I do urge that, you know, there's nothing. Once you understand Dijkstra, you'll realize that there's not that much special about this problem, other than maybe use a bit mask if you're not familiar with it. But yeah, and we'll go over the complexity in a second, right? But yeah, okay. So then, yeah. Otherwise, if boat is on the right side, we have to get to the left side. Well, if it's on the right side, then and we see all the nodes, then we can just return cost, and we're happy because that now everyone is home on the right side. Otherwise, we bring one person back, right? And I had and honestly, I did a lot of copy and paste, which led me to debugging for about 10 minutes because I just had a typo on the XOR to kind of convert the mask. But yeah, but you can work all of this out pretty straightforward way. And this is also standard Dijkstra, so I'm not gonna go over it. And then at the end, yeah, of the loop, if we visited all the states that we can and we haven't seen it, the end state, then we return -1. So this is very basic Dijkstra's algorithm. And that's it. So what's the complexity here, right? Well, we're doing h on the number of states. So this loop will happen for one of the every state. And how many states are there? Well, mask is 2 to the n. Stage is, I think, m, which is 5, by the way. This is 2 to the 12th. And then boat is either 1 or 2, right? Or 0 and 1, sorry. So there are 2 instances. And we multiply them all together. What is this? Like 496 or whatever. And then times 10. So this is going to be about 40k states, right? States. That means that this loop will happen at least, at most 40,000 times. Though I think a lot of them are not possible, but maybe I'm wrong on that. But yeah. And in each loop, how much work do we do? Well, we do this possibility thing, but at worst, there's this thing, which means you have k. So at the worst case, it's going to be n choose k number of things. I mean, we pre-process this. This is all of this pre-processing step. It's going to be all of 2 to the n times n, right? Because this is all of 2 to the n, and this is all of n, so it's 2 to the n times n. But once you did that step, and remember that this is only 12, so this is 2 to the 12, which is 4,000 times 12, which is like what? I don't know. Let's just say 40,000 again, or 48,000, or whatever it is, right? But yeah, then now this that means that after we pre-process and filtering out, that means that it's going to be n choose k number of things in p, right? Write it out. And choose k number of things, and of course the n choose k is going to be 12 choose 5 is the biggest one, which is only about 12 choose 5 is equal to 796. So it's going to be 40,000 times 6, which is honestly a little bit big, but I just imagine that a lot of those states are not possible, and that's basically it. And of course, each of these we do a heap, so which is log of 40,000, which is not small but not big. I think the key thing is recognizing that a lot of the states are just not possible, and that's basically it. And keeping in mind that this for loop does all this. The inside stuff doesn't happen to a lot of them because of this filter as well. So yeah, and then the other one's even easier. This is just O of n, so it's even cheaper to bring people back. But that's basically the idea. Is converting the DP into a Dijkstra, because this is the shortest path, and they even tell you, right? It is minimum time problem. So maybe that should have been a hint. I mean, I wish I knew, so I don't know. A silly mistake. And again, I spent 10 minutes debugging a typo because I copy and paste, and I had it like this for a while, and I just couldn't figure out why it wasn't working. People were not getting brought back. So yeah. Anyway, that's it. That's all I have. Let me make this smaller. Let me show you the pre-processing step, the heap setup. Yeah. Boat is equal to 0. I mean, all these is heap, and then now bring one person back, boat thing, and the base case is here, actually. And that's it. That's all I have with this one. Let me know what you think. Thanks for watching. And yeah, you can watch me solve it live during the contest now. Not bad. We did that one in another 5 minutes. Okay. Given n individuals, let's see. K, all the numbers are small, so we'll see what happens. N individual single boat. K number. M stages. There's so much things to keep in your head. What is going on? N, K, boat, J, M sub J. Okay, whatever, sweets up. And there's some fraction things going on, which is kind of wonky, but okay. Each individual has a okay. I mean, seems like a bit mask problem, but it is such a weird thing to look. And at this point, a lot of people did solve it, even if it is from cheating. But in any case, I don't know what I'm reading at. Look, there's so many things, right? So the N people, both K people, M, what is M? M is equal to multi.length, okay. So M is equal to length multi, okay. And then what is time? We don't even need M really, but what's time? Time sub I is, I need a thing anyway. Time for I to cost alone. Okay, and then the rows. The group G takes time maximum times of I amongst its members, multiplied by most of j. Okay. The stage advanced by, what does that mean? What is a stage? What the hell is return time? Times of odd. Okay. What is the current stage? Okay. I guess start at stage 0. Did they tell you they start at stage 0? I guess so. But they should make it more obvious. If you're gonna define all this stuff, at least define problems. Okay. Return the minimum total time required. Okay. So I mean, it seems like it's just bitmask DP, right? But not to say this is easy, of course. But what's this M again? M is, oh, the cycle thing. That's fine. Time, that's fine. I mean, it is just bitmask DP, I think. I don't know that, I mean, maybe there's a matching thing, but okay, we have to define it a little bit better. So we could define it twice, right? So, okay. Cross 1, maybe. Mask. What else do I need? The mask. And then what else do I need? The problem is that the way that I structure this, maybe there is a cycle, so it's not, but you'd have to bring a person back. And if k is equal to 1, okay, I guess k is equal to 1, so we always make progress. Okay, so if k is equal to 1, then we just return not possible, maybe, unless there's one person. Okay, so maybe we have to write that. If k is equal to 1, assert force. I'll write it out later, but I just want to have it here so that I don't forget to counter it. Okay, so that means that we always make progress. So then what else do we need? I guess the stage, is that it? I think that's it. Everything else doesn't matter. Right? Okay, so then now we want to say, maybe we're going to pre-calculate all the ways to get people. I guess we don't always need to take every person, right? It's up to k. Not. It's not. Yeah, it's not exactly k. So that is actually interesting. I mean, it's just a lot of setup. I don't think this is that hard. Conceptually, maybe. Maybe I'll find out what the hard part is later. But okay, so it's up to k. So we should pre-calculate the possibilities, right? So p is equal to, right? So for something like that. I guess we just started 1. I was gonna say, always want to send someone. Okay. Do we ever want to send one person? I mean, you do if you only have one person left, right? Yeah. Actually, let me actually. Could even cache this. If I need to optimize, I can optimize. At this point, if I need to optimize, I blame it on Leetcode and not me. But okay, remember the cache though. Okay, so then now, do we ever want to send more than one person back? Maybe not. Doesn't seem like it, but okay, fine. So there's no base case for C as in possible, mask, if mask and C is equal to 0, then we cross 2. Stage is 4 of D. What is D? Time D. What is D? Max time I amongst its members. Max time I amongst its members. Multiply by most of J. Okay, I mean we should reprocess this into here if that's the case then. Okay, so for J in range of N, if I or JJ, right? Okay, so then now, right? So then now we have IT in this. So then it's going to be cross of this. Stage is going to be stage plus, okay, well, let's just say D, which is time apparently. Do we have more? Okay, it is fractions. Okay, so D, what is, okay, let's see. What does mod M mean? Oh, I guess it's just that, but that's, it wraps around anyway, so whether, how many times, okay, whatever. D is equal to T times multiple of stage, right? Yeah, so it's stage plus into D I hope this works in the sense that like fractions are always ridiculous. I could see that, honestly, I could see that this messes up. Unless we're meant to, no, this is, they're given to you in a fraction. This, I don't know that there's an easy way to handle it. So I don't know. Or that is up to Leetcode not being too dumb. So yeah, okay, so then this is plus D. Okay, so best is equal to infinity. In this case, actually, you could use infinity, math.infinity, because we're using a double. It's min, isn't it? Yeah, okay. And then we just return cross 1 stage mask of 0, 0, right? Of course, we need to write cross 2. This is crossing back. So now we want if mask is equal to -1, then we're done. And then we could return 0.0. Otherwise, but we have, I have to do some check for moving one person. Because one person never makes sense unless it is the last person. I have to do that. Otherwise, it's going to give me an infinite loop. Okay. So then now D is equal to time of I times multiple of stage. Okay, so then now we want to flip off this guy back to the other side. And then same thing. But again, this makes me feel not so great. It's so easy to make a mistake here. Okay, I think this is good. I mean, I know that this made one infinite loop, but I just want to see this. Oh yeah, I forgot about this. That's why I had it this way. If k is equal to 1, if n is equal to 1, then we return, then it's just one person, so then you return times sub 0 times mode of 0, and that's your time. Right, and then you're done. Otherwise, return -1.0 apparently. Should infinite loop if I'm right. Okay, that's what I meant. So okay, so you have to check one. Okay, yeah. Okay, let's just say c is equal to I bit count. Right. ITC. Yeah, current, and then now bit count, right? Yeah. Okay. If b is equal to 1, then we only want to do this if it is the n. So then if then we do it. Then we do it. Otherwise, if this is the case, so if this is not the case, we continue. Okay, I think that's all I need. Okay, 14.5, -1. Am I confident? Yeah, YOLO. Maybe some silly mistakes, but that's fine. Hopefully no timeout. This isn't even close. That's actually not great. Did I do the most? Slows down, so you multiply. No, that's right. That's the part that I wasn't sure about. Maybe I should have been sure. I mean, this looks okay from that though, right? Oops. Okay, so this isn't even close. Why is it not close? I put 72.8, you have 47.8. Am I doing the stages wrong? So time is 40, we have 1. You have 2 people, k could be, or 3. M is 4, what is M again? Oh, you just take ones, right? So that means that you take 40 times 1.82. Oh, So, oh, wow, that is a tough case. So basically you want to take the 1, so then take the 1 back twice, get the 1.1, and then ship both. So I was wrong on here. How did I check that? So we do want to try it. That's a good case, actually. Did this refresh? Ah, just refreshed. Yeah, didn't do so well. Definitely don't want to cycle, but I was wrong about this. So you would ever So okay, so you would only do 1. When would you ever move? Might have to take this case out, but I have to do all of them at the same time. How would you get that one? How would you get the summation? Okay, so this is trickier than I thought for sure. At least top down. Can I do it bottoms up in some way? That's it, isn't it? Dijkstra. Yeah, it's Dijkstra, isn't it? Okay. I guess I. Okay. Wow. I mean, okay. It is shortest path after all. Okay, fine. So then, okay, let's rewrite this. Okay. Push. So then now we have mask, stage, boat. Is that it? That's the combination. Yep. Well, in the cost, so 0. Okay, so actually this isn't even a real thing, but it's just my thing. Okay. So cost is 0, max is 0, stage is 0, both 0, right? Okay. Okay, I mean, okay. That's not so bad. It's just, I guess I just really expected DP. Right? I didn't see the psycho because I didn't see this case. Once I see the psycho, it's not that bad, but okay. So the cost, mask, stage, boat is equal to here. Should I put it in a set? Let's just do this for now. I don't know if that's the cleanest, but we'll do it for now. Okay, right. And then now if boat is equal to 0, then we basically do this thing, right? For CT, B, and P, maybe just copy and paste. This is no longer true. That's fine. Or that part of it. This is still true though, maybe. So D, and then now we have new cost, new mask, new stage, and new boat. New boat is easy, right? New cost is going to be equal to cost plus D. New mask is equal to mask or C. New stage, equal to stage plus int of D mod M. And then new boat is just 1 minus boat. And then now we just have to make sure that this does not exist, and mask and stage and boat if this is not in distance or distance of, okay, let's call it key. Oops. If key is not there, or length of key is if the distance is greater than n cost, no, not n cost, no, it's greater than n cost, then we hip q dot hip push. I'm forgetting basic Dijkstra things because I'm a little bit whatever. For example, we have to write something like if cost is not equal to distance of stage boat, then we continue. Okay, is that all Gucci? I think so. We already wrote, I mean, I already submitted it, so they have a version of it. Okay, and then now going back, I don't know if this is true anymore, but okay. So boat is equal to 1, then we can say if mask is return cost, actually. Yeah, because it's Dijkstra, you have to do it on relax. Otherwise, one person have to come back. Let's just copy and paste some of this. Okay. Okay, so let's just copy this. Yeah. I think this is the only difference, assuming all the other stuff is correct. And then we have to put it into heap, right? So with this thing, we probably could have, there's a lot of overlap in this, but yeah, and then if you cannot find any, you go 1.0. I think that's it actually, right? Maybe, hopefully, heap q.heap pop. Oh, I didn't put the okay. Yeah, because everything else should be invariant, right? Why is that not true? Oh, I didn't put this in. I'm so dumb. Okay, 5. This is well, this answer is right, but the 11.5 I think is not, right? Or why is it giving 11.5? Huh? Did I do something wrong? Not so great. Did I do something wrong? And both stage the time supply if mask is so both is equal to 1, right? Where is it wrong? Return to low. Okay. I mean, we had it right. The DP is right. So then why is this wrong? I'm so tired. Okay, fine. Let's take a look. Okay, so okay, so so we want 7 to 11.5. Where is it going from? Mask 7 stage boat. That's right. Something is missing something. Okay, so debugging is so painful. Okay, so 2.0, this is probably right, maybe. Oh no, 8 minutes. 0 and 2. So we send 0 and 2. But this only sends like one dude. 0 and 2 is 5. So 5 is 8, and that's right. And returns along. Returns along 0, so 4. 4. 4, 3? There's no 4, 3 here. That's weird. Weird. 4, 3. Do you see 4, 3 anywhere? No. 4, 3. Where's 4? Because it went from stage 4, 2 to 4, 3. So this should push one. Where the boat is on. No, it's 420. Because 421 is wrong. It's 52, and then 52 should push the 420, which takes 1.5 minutes. That's a 9 point. Did I multiply something wrong? Multiple stage times of I, T. Man, I'm spending so much time debugging. It's sad. So this is right, but it pushes this, but it pushes 14 when it should be 1.5. No, it should push 4.3, not 4.2. I guess that's wrong. What is D? Is that why D is equal to time sub I is 2, stage 2 is 0.75, so it's 1.5, right? I am so sad right now. It's such a waste of time. Okay, so 5.2. So there's a 1.5 here. But do I get this wrong? It should be 9.5 and 3. Right? Okay, so I'm putting way too much now. Okay, I don't need to heap in my printing. And I don't like this UI. It's just so, like, I have to tap on like 4 things to remove the right thing. Okay. Okay, so you have this thing, you have 1.5. To heap distance map, we want 430. 430. Alright, this is just, I can't even scroll left. The reason why I'm highlighting is because I cannot scroll right, because Leetcode UI is crap. I don't see it though. Why? Oh no, that's an XOR. That's why. Okay. That is. I copy and paste, and then I just forgot that I shouldn't have copied and paste. I guess that's the TLDR really. But okay, submit. Yeah, I mean, silly mistake on Q4 on a copy and paste error, but I mean, generally okay, just a lot of silly mistakes. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about, well, today's problem, this contest, everything in between. Yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.